Assalamualaikum. We are Group 2 and we will be presenting our lab proposal for Experiment 6 which focuses on the synthesis of biodiesel. Hi, let's now begin with the introduction. Global energy demand has been rapidly increasing, especially due to globalization. As shown in this slide, this rise is influenced by various sectors such as politics, the economy, culture, and lifestyle. Energy consumption is now growing at a pace far beyond previous expectations. When we look specifically at transportation, it remains one of the largest consumers of petroleum-based fuel like diesel and petrol. Unfortunately, fossil fuel reserves are depleting quickly due to high demand. This highlights the urgent need for a sustainable and renewable fuel source to ensure energy security for the future. Before diving into the experiment itself, it is important to understand what biodiesel is and why it is significant. Biodiesel is a renewable fuel derived from sources like vegetable oils, animal fats, or even used cooking grease. One of the biggest advantages is that it can be used in diesel engine with little or no modification, making it a practical alternative to conventional diesel fuel. Biodiesel is typically produced through a chemical process called transesterification. This reaction separates glycerin from fats or oils, leaving behind methyl esters, which is the chemical name for biodiesel. Now let's look at why biodiesel is a better option in many ways. First, it burns cleaner than petroleum diesel, resulting in lower emission. It also significantly reduces greenhouse gases, helping to combat climate change. Another key benefit is that it's biodegradable and far less toxic. In fact, it's less toxic than table salt. Lastly, biodiesel is environmentally friendly and sustainable, making it an essential part of the transition toward greener energy solution. Now that we understand what biodiesel is, let us move on to the problem statement of our experiment. The main goal was to explore an effective synthesis method for producing biodiesel in the lab. Our focus was on using palm oil, methanol, and sodium hydroxide as the core reactant. One of the key challenges in biodiesel production is determining the optimal methanol to palm oil molar ratio. If this ratio is not well balanced, it can affect both the yield and the quality of the biodiesel produced. Based on that, our objective was twofold. First, to study the lab-scale preparation of biodiesel using these three substances, palm oil, methanol, and sodium hydroxide. And second, to examine how varying the methanol to palm oil ratio influences the overall yield and quality of the biodiesel. This formed the basis of our experiment and helps guide the methodology and analysis in the following slide. Let's now look at the scope of our experiment. Our goal was to produce biodiesel on a laboratory scale through a process known as transesterification, using palm oil as the feedstock and methanol with sodium hydroxide as the catalyst. A major variable in our experiment was the methanol to palm oil molar ratio. By adjusting this ratio, we observed its effect on two important factors: the yield of the biodiesel produced and the quality, based on appearance and how well the biodiesel separated from other phases like glycerin. So now moving on to the significance of this experiment. This project demonstrated a practical and sustainable method of fuel production that could serve as an alternative to fossil fuel. It also shows how renewable resources such as palm oil can be effectively used for energy generation, which is essential in today's push toward greener energy solution. On top of that, this lab gave us hands-on experience in environmentally friendly chemical processes, and it helped promote a stronger sense of environmental awareness within the fields of engineering. Overall, the experiment wasn't just technically informative, it also emphasized the growing importance of sustainable practices in science and engineering.
This is the methodology for the biodiesel synthesis. The apparatus involved in this experiment is a liter beaker, electronic balance, hot plate, magnetic stirrer, aluminum foil, measuring cylinder, separating funnel, and thermometer. And then the material is palm oil, methanol with the different ratio, and then sodium hydroxide with 2.22 gram. So this is the methodology for the biodiesel synthesis experiment. So the first one, we need to measure 106.11 milliliter and 212 0.23 milliliter volume of methanol using the measuring cylinder and quickly pour it into a different beaker. And then we need to cover the beaker with an aluminum foil and tighten securely. And then we need to weigh the sodium hydroxide powder into two different beakers, which is 2.22 gram. And then add both of the sodium hydroxide powder into the methanol and quickly cover the beaker. Then agitate the beakers gently. The reaction produces sodium methoxide. And then pour 500 milliliters of palm oil into two different beakers and heat up until reach 55 degrees Celsius using the hot plate with a magnetic stir. And then maintain the temperature at 55 degrees Celsius and allow the stirrer to continue running while adding the sodium methoxide into each beaker. Then cover the beaker with aluminum foil and stir rapidly for about 30 minutes. After that, the cool compound left for a while. So when the compound becomes warm, transfer the content of the beaker into the separating funnel and set a timer for 30 minutes for separation to take place. After that, drain off the lower layer of glycerin and then transfer the palm oil and methanol. Observe the two layers of liquid, which are biodiesel at the upper layer and glycerol at the bottom. When the glycerol indicates, it is the presence of a successful reaction. And then collect the biodiesel into another beaker and weigh using the electronic balance. And then record the result. For safety procedure for this experiment, first we need to handle methanol with extreme care as it is a toxic, flammable, and it can be absorbed through the skin. And then avoid skin contact with sodium hydroxide, since it is one of the corrosive chemical. And then we need to ensure that proper mixing to avoid overheating and potential hazards. Dispose of waste materials according to local regulations, and then clean up all the equipment after use to ensure no residue remains.
The analysis part is where the mathematical equations and other analytical methods is being used to analyze the experimental data from the biodiesel synthesis, which focus on the effect of methanol to palm oil molar ratio on biodiesel yield. So the mathematical equations that we will use is, the first equation is to find the weight of palm oil. Number two is number of moles of palm oil used. Number three is weight of NaOH used, which is the catalyst. Number four is volume of methanol used for molar ratio of 1.1 to 5 and 1 to 10. And the last one is data analysis method. So the main method to analyze the result will involve gravimetric analysis, which we will determine the weight of the produced biodiesel. So the weight of the empty beaker and the weight of the beaker contain the biodiesel will be measured using electronic balance. So the difference of those two will give the weight of the biodiesel. For experimental plan, which includes the data and variables to be investigated, methods of measurement and task delegation among our team members. So I will start off with the identification of data, which is the variables that will be included in the experiment. So the first one is constant variable, which we constant the volume of palm oil and the amount of catalyst used, which is NaO. The second one is independent variable, which is methanol to palm oil molar ratio, and we will investigate the difference between molar ratio of 1 to 5 and 1 to 10. And the last one is dependent variable, which is the biodiesel yield. So the initial parameters that we fix is volume of palm oil, which is 500 milliliter, and the amount of catalyst, which is 2.22 gram of NaO. So this value will be obtained using a 1 liter beaker and electronic balance. And we also fix the experimental condition, which is the stirring time stirring time 30 minutes, stirring speed 350 rpm, and the reaction temperature, which is 55 degrees Celsius. So all of this will be controlled at the hot plate, while the temperature is also will be monitored. The outline of our team plan and the task delegation. So our group consists of 4 members, and before the experiment, so we did a preparation including gathering all necessary materials and equipment required for this experiment. We review the experimental procedure, we understand the theoretical background and safety precaution, and we also make a decision about experimental parameter. For instance, the specific molar ratio of palm oil to methanol, which is 1:5 and 1:10, will fix the experiments. We will follow the outline step by paying close attention to those accurate measurements, maintain the control variables such as the reaction temperature, stirring time, and stirring speed, and we will also carefully observe the reaction process and product separation. So throughout this phase, we will follow the safety precautions, including proper handling of chemicals like methanol and sodium hydroxide. After the experiment, we will process to collect the raw data by performing calculation to determine the percentage yield of biodiesel. So then we will interpret this result, compare the yield obtained from different molar ratio, which is 1:5 and 1:10, and we will identify any potential sources of error, such as the possibility of high yield, which would suggest impurity. So this post-experiment is important for us to improve the experiment. So this is the task distribution among our team members.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Afina Aina binti Ahmad Razani, and I will continue for the anticipated results. So the first one, we have the data to be calculated. In this table 5.1.1, the experimental data of biodiesel synthesis. So we need to calculate the volume of methanol used using the ratio 1:5 and 1:10 for each of the sample 1 and sample 2 respectively. Next is we need to calculate the weight of the biodiesel with the beaker and weight of the biodiesel produced, which we will subtract the beaker, and also calculate the percentage of yield by using the formula stated in the analysis. So, and then we will compare between the sample 1 and the sample 2 of their percentage of yield. For the expected trends, the first one we have the effect of molar ratio on biodiesel yield. So it is suspected that sample 2 utilizing a ratio of 1:10 methanol-to-oil molar ratio will produce a higher biodiesel yield compared to sample 1 with a ratio 1:5. So this is due to the excess methanol driving to the transesterification reaction forward in accordance with Le Chatelier's principle. So next trend is for the sample 1 yield estimation. So the sample 1 is anticipated to produce a biodiesel mass of approximately 418 gram, corresponding to an estimated yield around 90 to 95%. So this result aligns with the standard reaction efficiencies reported in literature when near optimal molar ratios are employed. So for sample 2 yield estimation is expected to yield a biodiesel mass exceeding 500 gram with a calculated percentage yield possibly surpassing 100%. So such an outcome may result from incomplete phase separation because it is over 100%, right? Or the presence of residual methanol, glycerol, or soap that may artificially inflate the final biodiesel weight. So as for the purity and the separation limitations, the biodiesel will not subjected to washing or further purification. It is expected that residual byproducts such as methanol, glycerol, and salt will remain in the final product. So these contaminants may impact the accuracy of biodiesel mass measurements and compromise product purity also. Next, we have the separation issues at high methanol ratio. So, although the 1 to 10 ratio is expected to enhance the biodiesel formation because it is high in the ratio, but it may also lead to separation difficulties. Excess methanol can increase the solubility of glycerol in the biodiesel layer, reducing product clarity and their purity. And then the last one, what we can conclude from here is that trade-off between the quantity and the quality. So overall, the 1 to 10 ratio is predicted to yield greater biodiesel quantity, but with lower purity and potential processing challenges, while the 1 to 5 ratio is expected to produce less biodiesel but with greater phase separation efficiency and fewer contaminations.